So we don't need to show that every corresponding part in each triangle is corresponding, right? There are some shortcuts. So on the notes page, I was smart enough to just put that in there this time. Thank you. Yeah. Some things we need to know. Okay? So vertical angles. I don't know if you ever heard of those, right? Vertical angles are just formed by two intersecting lines. Okay? And when you hear the word vertical, it doesn't necessarily mean up and down. Okay? So you got to kind of be fungible with that term. Vertical angles are just formed from the angles that are across from each other. So like angle 1 and angle 3 are vertical angles. And name me another pair of vertical angles in here. Angle 2 and angle 4. Now, vertical angles, and you need to know this, are congruent to each other, okay? So if I have this situation here, I can say that angle 1 is congruent to angle 3 because they're vertical angles. And I can also say that angle 2 is congruent to angle 4 because they're vertical angles, okay? Are we good with that? Now, another thing we need to know, when we get to these triangle shortcut thingies, is something called the reflexive property, okay? Reflexive property. What the reflexive property says, and you're going to think, wow, man, it's so ridiculously obvious. Why the need to even state it, okay? The reflexive property just says that everything is congruent to itself, right? Everything's congruent to itself. Would it be a true statement if I said shut is congruent to shut? Yeah, everything's congruent to itself. Okay? So if I have a segment AB, I could say AB is congruent to AB. Or if I have angle ABC, I would say it's congruent to angle ABC. It's congruent to itself. Well, why the need to state something so ridiculously obvious? Well, when we start doing proofs, we need reasons for certain statements we make, right? I told you when we try to prove something geometrically, we'll have a column of statements that we make. Like maybe we'll state this angle is congruent to this angle itself. And we always have to have a reason, right? So this gives us a reason for certain statements that we make when we get the proofs. Okay? We're setting up to start proofs, so we get some information we need. Okay, so now on to triangle congruence. So we don't need, when we have triangles, if we want to prove that two triangles are congruent, we don't need to show every single corresponding pair of sides and every single corresponding pair of angles are congruent to show the triangles are congruent. We have some shortcuts, okay? So the first one is, you'll have to commit these to memory, okay? Don't worry, you'll use them enough over and over again, you will. And I'll have a little thing up on the wall there to help us initially, then I'll take it down, okay? So if I had this situation, triangle ABC and DF, notice I have congruent, there, and there, right? If all three sides of one triangle are congruent to all three sides of the other triangle, then the triangles are congruent. Okay? I didn't have to say anything about the angles, right? I didn't need the angles at all. I got all three sides. Okay? The next one we have, and you have to notice the order here, side angle side, or SAS. So we got SSS, then SAS. So this says if two sides of one triangle, and we have to be careful, and the included angle, what does that mean? So do you see these two pairs of sides that are congruent? Yes, I do, Mr. Hudrick, because I'm looking at this, right? You see this angle, these angle pairs that are in between the two sides? That's the angle, in between the two congruent pairs of sides, right? So this doesn't work, side angle side doesn't work with if the angles here or here, right? We have to call something different. So that's side, SAS, okay? So if you have that situation, if those two sides we prove angle congruent, without knowing anything about the other sides and angles, we can say the triangles are congruent. I've abbreviated this. Usually that's what you'd write, okay? So we've got side, 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 angle, side. Now we also have, kind of like this one, angle, side, angle, okay? So I have two triangles, and do you see this angle and that angle congruent here and here? And you see the included pairs of sides, included meaning the sides between the two angles are congruent. Okay? If that's the case, then these triangles are congruent by angle, side, angle. We got me? Okay? We have another one. And notice the order now. Now it's angle, angle, and one of the sides that's not between the two angles. Okay? So like this. Here we have angle and then angle, here and here, and this pair of sides that's not included between the two angles. If you find that to be true, then the triangles are congruent. And you would say by angle, angle side, or by AAS. Okay? Now, this one's a little different, right? Hypotenuse leg. What kind of triangle has a hypotenuse and a leg? Or legs? A right triangle. So this one only works for right triangles. Okay? Because, well, these don't have hypotenuses, right? But these will work for right triangles as well, but this won't work for any other thing. So if you have a right triangle, okay, and you have a pair of legs congruent and their hypotenuse is congruent, there's those two things, right? You have congruent triangles by hypotenuse leg, or HL. Okay? So we have a few methods here to prove congruence.
So we want to do like the abbreviation.
Oh, absolutely. Yes, yes. And mathematics, geometry, whatever. Isn't algebra just all about abbreviating, right?
I don't remember it.
But the language of algebra is all a convenient abbreviation for everything, right? Okay. Yeah. So as long as you're clear as to what you know, if the reader understands your abbreviation, it's fine. So you do want to be careful with that. Yeah, like these are going to be used when we do proofs, right? And if as a reason in the reason column, if you just write triangle congruent to triangle, and next to it is the reason in the other column SSS, everybody knows what you mean. Okay. So we got side side side, side angle side, angle side angle, angle angle side, and hypotenuse leg HL. Okay. Now, one thing kids always try to do, and there's a way they try to prove triangles congruent, and it never works. Okay. So there is no such thing as angle side side congruence. Okay. Right? You cannot prove there is no angle side side. Now, I don't know, kids have a hard time remembering that you can't prove triangles congruent by angle side side. I don't know how you'll be able to remember that. Maybe there's some sort of device, some kind of memory trick you can use, right, to alert you that triangles are not congruent by angle side side. Okay? So you choose your own way to remember that this doesn't work. Okay? Whatever that way is. You have to, you know, hang it on the fridge at home or something like that. You know, look at it every day. You can't prove triangles congruent with angle side side. And I swear to God, I see kids do it all. As soon as I get done saying that, and they'll prove two triangles congruent, and the reason will be angle side side. Why?
So this is just how they label it.
Yeah, the reason. Like this, when we get to proofs, you're gonna have a statement, and like your ultimate statement would be triangle ABC congruent triangle DEF, and your reason, if you spelled it all out, will be side angle side or side by side, but not angle side side. Okay.
No, but.
Right, Mrs. Petrin? Mrs. Petrin is always trying to prove triangles congruent with angle side side.
Never. Well,
Always.
maybe it's because of the person who lives across the hall.
Conceivably.
See,
I'll start that.
Okay? Everybody got that? So, yeah, you got to know those. And it seems like a lot, but what usually happens is we do so many things with them, it'll just get into your memory, hopefully. Okay? So let's go back and take a look at some of the stuff they have here. So here in this first row, they're talking about side, side, side congruent for triangle, okay? So in the first case here, clearly side, color, how do I do that? Let's make it side here, these two sides, and these sides. So those two triangles are congruent by side, side, side.
So what if the angle looks the same, but
Well, for side, 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 we don't need anything about the angle. Oh, that's a good point. Listen carefully. And you've probably been told this, right? If you're looking at a diagram and two angles look like they're the same measure, are you safe to assume that?
No.
No.
Yeah. Maybe.
No.
Or
Or if they look like right angles, can you just say, yeah, they look like they're right
Have that
angles?
little line.
No, correct. Either you need to be told it in the directions, or it's got to have the mark in it, all right? Because maybe it looks like it's 90, but maybe it's really 89.99999, which then ruins everything, right? Okay. How about this middle one? Can we prove them congruent by side, 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 or the three pairs of sides congruent?
Yeah.
Really? I only see those two and those two marked. That's only two pairs. That's side, side.
But the one is the same exact thing.
They share a side. Why is that side congruent to itself?
Because it's the same exact thing.
What property?
Similar. No.
What's the property that says everything's congruent to itself? Go back to your notes. The ones I gave you on the other page. Yeah, it reflects the property. So right here, see, that's where it comes in handy. So we can say that BD is congruent to BD by this. By the way, see how I abbreviate that? You do that. Is my abbreviation clear for what I meant? Especially if you're a math student? Yeah? Okay. How about the third one?
It's the same thing.
Same thing, right? They share a side. So again, we have HJ congruent to itself. HJ by the reflexive property. Now you see why that is obvious but useful, okay? Okay, these next ones, so they're doing what? Side, angle, side, or right?
Some.
Here's what they do. Whoever made this curriculum here, apparently their software will not allow them to make angle congruent marks, okay? So what they do is they put like an O here. That means that that has an O and that has an O, so they're congruent, right? Or maybe there'll be like a little X or some little symbol. Same means they're congruent, right? But I like to go through and just, yeah, I don't like it, so I do that. This here, okay? So in this one here, well, we could use side, side, side again, just like the other two, right? But do you all see that this is side, included angle, side, side, angle, side, right? The two sides and the included angle, okay? Over here, same thing. The two sides are congruent, two pairs, and the included pairs of angles are congruent. Over here, why are these two angles congruent?
Was
What
the
kind of angles are they?
angle.
It's in your notes, I just gave it to you.
Wait, what kind of angle?
They're vertical angles, and what do you know about vertical angles? They are congruent, right? Right here, vertical angles, congruent. See my abbreviation? Okay? Vertical angles are congruent. And so that gives us side angle, side triangle congruence. Okay? Let's move down here. Now they're on to angle side. So see, look at this. See an O and an X, right? I don't know what, but anyway. So these guys are congruent, and I'll use a double mark here because I hate, see what I mean there? Okay? So now, that's two angles, two angle pairs, and the included side pairs, right? So these triangles are congruent by angle, side, angle.
So up to the top, where you mean where T is?
Mm-hmm. No, not necessarily. The only way, like if you were given that, the only way, not the only way, but one way you know that these are congruent is if somebody told you that this segment is an angle bisector of that. They didn't tell us that. Okay? You know, like a segment bisector splits a segment into two congruent. So an angle bisector splits an angle into two congruent angles. They didn't tell us that. Okay? So we can't use that. All right, the next one. These are congruent. And I'll use a double here. Okay, are you getting the idea? So that's two angles in the included side. All right? Okay. The next part. Oh, this is the third angle. Let me just run through this real quick. We'll address it more specifically later. So down here, do you see, and this will be useful, these two angles are congruent, and then these two are congruent to the other, right? If that's the case, could we just say that these third angles are congruent? Well, I mean, so what do all the angles, what do the angles in the triangle add up to in every triangle? 180. And if these two are congruent to these two, and they all have to add up to 180, doesn't that mean these have to have the same measure? And that's called the third angle theorem. Okay, I'll just write it down here. This is called the third angle theorem. Okay? So if you have two angles in one triangle congruent to two angles in the other triangle, the third angles are congruent. Okay? Because they have to add to what? 180. If you got same, then you got same for the other one, right? Okay? All right, let's flip over the page. They got a lot of baloney. The top there's crossed. I'll probably take that out. Let's go down here. Now, are the following pairs of triangles congruent? If they are, you're going to write one of these. Okay? They tried to come up with some way for angle side. It's no. They really tried to overcook their grits, and they're just full of, you know what. Now, can we say, given what we're given there, just given what we're given, that those two triangles are congruent by one of our ways, side, angle, side.
Yeah.
Okay, we've got side and side. What else is congruent in here? What? What else is congruent? Huh? Why? What tells you that? No. You're conflating. Okay, you're mixing that up with the third angles theorem. There's no third sides theorem, right? The sides don't add up to 180 or
So
anything like
is it
that,
an
right?
equal side though?
Well, we only have two pairs of side. We have SS.
Those two are the same, then the other one has to be the same.
No, they don't. No.
So
Again, you're doing the third angles thing to sides.
So it's not congruent.
It's not.
It works with the third angles because the angles have to add to 180. Sides don't have to add to anything at all. So the answer here is no. Well, we got a side. Now, how about here? You just mark these 100%.
Side, angle, side.
Okay, there's two sides, you include the angles. So that's a yes,
That's it.
SAS.
Yes.
And the next one, yes, all three, they're good. Yep, side. And the last one, yes or no?
Yes.
Why? Well, we have a side and side.
That's a
But there's a
vertical.
three.
Vertical angles are congruent. There we go. So it's yes by what? All right, you guys are getting this. Side, angle, side. Okay?
This is much easier to come up with.
Well, don't worry, it'll get no fun. All right, so you guys take a minute on the next page here.
Wait, so what does it mean by the complete? So it'd be,
Oh, triangle,
and then you say.
DEC congruent, right? And this is where you want to get the order right. So on these here, you're going to look at the diagram. Can they be proven congruent by one of our methods? Like you might have to flip back to your notes page, right, to look. If yes, circle yes. Put the triangle congruent statement in. Line them up right. And then which one you use. Side. Get the idea? Okay, so I'm going to take a minute and work down through these. What rigid transformation would map this triangle onto that triangle?
Reflection over relation.
A rotation, right? So this is, we can connect this now. Rotation mapping. Okay, it's another way to look at it. So we can look at it from the perspective of one of our triangle congruence theorems, or we could think of it as, if I spelled it right, rotation mapping. R-O-T-A-T, sweet Maria. I-O-N, mapping. Right, so now we have two different ways to look at congruence, and we can kind of resolve the two, right? Reconcile the two things. What's the criteria, by the way, again? It was what?
A,
Angle, side. Okay? You don't understand what?
Well, you have to do it like counterclockwise or clockwise, correct?
Yeah, well, it's going to be 180 degrees, so that the direction doesn't matter. It's 180. So, how about B? Did we get yes or no? So these are congruent to one another. Notice how I kind of offset my congruent marks there so it doesn't look like one swoop? Because that single swoop will mean something
Are the
different there.
sides all the one needs? Because it has two people.
What side?
So,
Oh, do they share that? Is it congruent to itself?
yeah.
Yeah,
By what property?
the property,
Reflexive property, right? So we know that that's congruent to itself, right? So we can say that CE is congruent to CE by reflexive property, okay? And so the criteria should go first. What would be the criteria? Which one of those are we using? Angle side? Looks like that side's in between the two angles. Angle, side, angle. And let's get a congruent statement. Triangle, what? Okay, let's say CDE if you want. Now let's get the other one correct. CED would be congruent to what? Or CDE to, what is it? CRE. Okay. Hey, what rigid motion would cause them to be congruent as well?
oh, I wasn't. Reflection.
Reflection. So this is reflection mapping. See how we're connecting this stuff now? How about in C? Is that a yes or no? See, that's congruent to that.
Side.
Yes,
By what?
by the reflection property,
Reflexive.
reflexive.
Yeah. Kind of so make sure you distinguish. Okay. Well, what do you mean by that? Like specifically, what
Like line CE.
segment CE? Careful. I'm gonna knock you guys. The line goes on forever. The segment ends and that ends, right? So you'll be tired when you get done. So CE is congruent to itself, right? So
it's
yeah, you get the idea.
side.
Yeah, side, angle, side. So let's do this. I'll start the other one. How about triangle DEC congruent to triangle what?
C.
T.
C.
Okay, so look, from D to E, I went down this side with a double congruent mark, right? Figure this way. And now from T, I got to go the same way, double congruent mark. See what I mean? So you can use your congruent marks to kind of navigate going around. So T, C, E. What kind of mapping, rigid mapping, would cause this? Is it a reflection? So if I reflect this over that line, wouldn't T be over here? And not map to, what is it? It's a rotation. Well, if that's what you thought, say it, man. How about D?
It's
Yes or no?
yes.
Okay, yes, why?
Because measuring on this from K and out is 4.
Okay, so let me mark them congruent. So that is congruent to that,
And then
and these guys, and then of course these angles. All right, so yes, by which of our criteria up there?
S.
So SAS would be the angle between the two congruent sides. Here's our two congruent sides, and we need that. Correct. So
So it's
So
AA.
SAA, no, SSA.
SSA is the same as ASS. Doesn't matter the direction you go. So keep that in mind.
Angle. Is it
Hmm? Well, if it's side, then the angle between them is side. Is that the case?
No.
So here's side and side. For SAS, it would have to be that angle, wouldn't it?
So
It's not. This is angle, side, side. Correct. So what's our answer?
Nah.
no.
No,
That's what it comes right here.
right? There's no angle, side, side, congruent. See the last one there? Yes or no? So let's see.
Yes.
Angle, angle, angle. Okay, so which of our congruence theorems will prove them congruent? Angle, angle, angle. Is that one of them?
No.
No, angle, angle, angle does not prove them congruent. Now later on,
Annoying.
all the angles will prove them similar, but they are not going to be proven congruent. So the answer is no. Okay? All right, there's only a couple of these questions here. So let's take a look at those. Now, I would recommend when you read these, guys, oftentimes it's really helpful to draw a quick sketch of a diagram to help your brain see what's going on, okay? So read this first one over, and I would definitely draw a quick little diagram. All right, so take a minute. See what I'm doing, guys? I'm just making a sketch here, and then I'm going to mark. See what they tell us here. Things are congruent. They tell you stuff's congruent. Come in here. So E and M. So I'm going to mark those guys congruent, and then EJ and MS. EJ and MS are congruent. Okay. I would highly recommend doing that, and that'll help you. And by the way, see that? Okay. All right. What do you think? 3. So remember, it's not going to make them congruent. So if we take EO over to MA, wouldn't that be side, angle, side? And therefore, one of our things. So that would be side, angle, side, wouldn't it? Any other thoughts on that? Go ahead, just say it. Huh? 4, JO mapping to SA. Well, wouldn't that make them congruent by one of our things? Wouldn't this make them congruent? And not? AKA side angle is also what? Angle side. So that's our answer. This one will make it not. Okay? Always make a little sketch. All right, next. So one maps onto the other by a translation, whatever it is, right? Are the triangles congruent?
Yes.
Okay, why would that be? They map onto each other.
Because
The translation is written, right? And so what happens? The surge of motion.
it was just moved up.
What can you tell me about all the corresponding parts? They are. Okay. Congruent. So parts would include all the corresponding side pairs, wouldn't it? And if all the corresponding pairs of sides are congruent, would the triangles be congruent by one of these? Which one? Okay. Let's frame our answer that way now, right? So I would say probably yes. The translation maps, how do you want to say it, corresponding sides onto each other? Yes, maps corresponding sides onto each other. Right? And if I say maps the corresponding sides onto each other, that means the corresponding sides are congruent. So, triangles congruent by what if all 3 corresponding sides map? SSS. See how we answered this a little differently now that we have a new way to look at it? Okay? Is what? Well, what my video? Yeah, we'll see. To help think about it, go ahead and plot those points there, okay? Oh, is that one question? And hey, look what it says here. This time it's not sequence. What is it? Single transformation. What happened to get well, so DEF is the image, so we started the line -1. x equals -1, right? So it's this line here, cuts the x-axis, right? So it's a reflection in x equals -1. Now let's think about why they're congruent. Think about the answer we gave the last time. So our answer might look like this. Reflections are, let's use isometric this time, why not? Isometric. Okay, so all corresponding sides are what? Yepper. Corresponding sides congruent. Okay, so the triangles are congruent by what? By side to side, right? Okay.